Hello students, in the last class, in the mechanical properties of fluids chapter, we discussed about Bernoulli's theorem and its few important applications. So in this chapter, you already studied the pressure and its formula as well as different phenomena executed by the fluid when it is at rest. For example, you studied about Pascal's law as well as what Archimedes principle. Next, when the fluid is in motion, it can have two types of motion. One is streamline motion and the other one is turbulent flow. Depending upon a particular velocity, when the fluid velocity exceeds a particular value, its flow becomes different. For example, if its velocity is small, it is usually having streamline flow, and when its velocity exceeds a particular value, its flow becomes turbulent. That velocity is called as critical velocity. And you also discussed about equation of continuity, that is velocity, how it is related with area of cross section of a tube, that is V is inversely proportional to A. And at the last part we discussed about Bernoulli's theorem and its applications. When a fluid is in motion, it can possess three types of energy. One is the pressure energy, second one is potential energy, and the third one is kinetic energy. The sum of all these three forms of energy is always equal to a constant. So based on this principle, you discussed about three important applications. First one is uplift of an aeroplane. Second one is blowing off of the roofs of the houses during the thunderstorm. We discussed about that application also. And another important application is atomizer, perfume sprayer, insect sprayer, how it is working. That can also be explained by considering Bernoulli's principle. Another important phenomenon exhibited by the fluid when it is in motion is viscosity. So viscosity basically it is the property of a liquid. By the virtue of it opposes the relative motion. It is the property of the liquid by the virtue of which it opposes the relative motion between the adjacent layers of the liquid. Best example, for example, consider two glass plates. They held in a standard manner. So on one glass plate, place a drop of water. On another standard glass plate, place a drop of honey or any type of oil, honey or oil. So normally we will observe, so liquid moves, so water flows very fastly and it reaches the surface quickly. Water flows out quickly and it reaches the surface. While honey or a drop of oil takes much more time in order to reach the surface. What does it indicate? Which means here honey is more viscous. Honey is more viscous and oil is more viscous when compared to water. Why these things happens means, for example, now let us consider a glass plate. So this is the surface of the glass plate. The layer of the liquid which is in contact with the surface is always at rest. The layer of the liquid which is in contact with the surface is always at rest. It is not at all moving. Now I will consider another layer C, which is at a distance x from the surface. This layer is moving with the velocity v. While I will consider one more layer of the liquid D, which is moving with the velocity v plus dv. So dv means small change in velocity. Its velocity is more when compared to this one. This layer of the liquid which is in contact with the surface is at rest. That means its velocity will be equal to 0. Another layer moves with the velocity v. Another layer moves with the velocity v plus dv. So here this layer which is in contact with the surface opposes the motion of the layer C. At the same time, the layer C also opposes the motion of the layer D. This relative opposition between the adjacent layers of the liquid, this property of the liquid is called as viscosity. So how this force is acting here? This force is acting normal to the surface of the liquid. So this layer opposes the relative motion of this one. That means the force is acting perpendicular. Here also this layer opposes the relative motion of this one. Here also the force is acting perpendicular to the layer of the liquid. So now here in this case the velocity of the liquid layer which is in contact with the surface is equal to 0. Its velocity is equal to 0. Its velocity is v. Its velocity is v plus dv. Velocity goes on increasing with respect to what? With respect to dx. So there will be change in velocity, small change in velocity dv with respect to small change in distance, that is dx. dv represents small change in velocity while dx represents small change in distance. This ratio of small change in velocity to small change in distance is called as velocity gradient. This is called as velocity gradient. A famous scientist named Newton formulated an hypothesis which is called as Newton's hypothesis. According to Newton's hypothesis, the viscous force F, which is acting between the two adjacent layers of the liquid, is directly proportional to. What does it depend upon? This viscous force depends mainly upon what? Area of the liquid surface, and also it is directly proportional to the velocity gradient. F is directly proportional to A and F is directly proportional to velocity gradient. Combining these two terms, you can write F is proportional to, directly proportional to area of contact and the directly proportional to velocity gradient. That is, F is directly proportional to A into dV by dx. In terms of some constant of proportionality, any constant, you can write F is equal to eta into A into dV by dx, where eta is a constant for a given liquid which is called as coefficient of viscosity. Where eta is a constant which is called as coefficient of viscosity, and there is a negative sign in this expression. There is a negative sign. What does it indicate? The negative sign indicates this viscous force acts in a direction opposite to the flow of liquid. For example, if the liquid is flowing in this direction, in which direction viscous force is acting? It is acting in this direction. If the liquid layer is flowing in this direction, here the viscous force acting in this direction. So that will be indicated by putting negative sign. So the negative sign indicates the viscous force acts in a direction opposite to the flow of liquid, where eta is called as coefficient of viscosity. By using this expression, how can you write the expression for coefficient of viscosity? Eta is numerically equal to F. If A is equal to 1 and dV by dx is equal to 1. Coefficient of viscosity is numerically equal to the viscous force acting between the two layers of the liquid which are having unit area of friction as well as which are having unit velocity gradient. So what does actually it indicates? Viscosity indicates the resistance acting between the two adjacent layers of the liquid, while coefficient of viscosity indicates the extent or the degree or extent to which the fluid opposes its motion. I will repeat once again. Viscosity is nothing but resistance offered by the resistance between the two adjacent layers of the liquid. What is the resistance? In general, resistance means opposition. So opposition between the two layers of the liquid is nothing but viscosity. Opposition for what? Opposition for its motion, opposition for its flow. That will be indicated by viscosity. So coefficient of viscosity indicates the degree or extent to which the liquid opposes its motion. It is the property of the liquid that will be indicated by coefficient of viscosity. So in general, viscosity means it is the property of the liquid by the virtue of which it opposes the relative motion between the adjacent layers of the liquid. Best example, by considering two glass plates. On one glass plate, put one drop of water, another glass plate, put some one drop of honey or any sort of oil. So normally we will observe, so water flows quickly while honey or oil takes some more time to reach the surface, which indicates honey or oil is more viscous when compared to water. Similarly, you can say viscosity of liquid is very much greater when compared to what viscosity of air. It is very difficult to walk in the water, while we can easily walk in the air medium. Reason why? Viscosity of water or liquid is higher when compared to viscosity of air. This is about viscosity. Next, Stokes law. Stokes law actually it gives the velocity with which the solid object is moving in any liquid medium. So I will consider a tube. Which is filled with some liquid. Any liquid. It may be water or oil or any liquid having the density sigma. This is the tube which is having the density sigma. This is the tube containing some liquid having the density sigma. A solid metallic sphere is dropped in this liquid medium. A solid metallic sphere is dropped in this liquid. Then what will happen? If this solid moves with some velocity. So it moves inside the liquid. Initially, it gets accelerated due to the acceleration due to gravity. Its acceleration becomes zero, and then finally it moves with uniform velocity. That velocity with which metal sphere moves in a liquid medium is called as terminal velocity. So what type of force is acting on this metal sphere when it is moving in the liquid medium? That force is given by Stokes law. That is given by F is equal to 6 pi eta into R into V. Metallic sphere experiences the force which is given by F is equal to 6 into pi into eta into R into V, where eta is the coefficient of viscosity, R is the radius of the metal sphere, where V is the velocity with which the metal sphere is moving inside the liquid. So this is about Stokes law. Stokes law established and it gives the force acting on a metal sphere when it is dropped in a viscous liquid. That is given by F is equal to 6 pi eta R V, where V is the terminal velocity. What is terminal velocity? The uniform velocity, average velocity with which the solid metal sphere is moving inside the liquid medium. So initially, when you drop a metal sphere inside the liquid, initially it gets accelerated. Initially it moves with some acceleration. Why means it is under the influence of what? Acceleration due to gravity. So here, when this metal sphere is dropped in a liquid medium, actually it experiences three types of forces. What are those three types of forces? One is the weight of the metal sphere acting vertically downwards. Another one is buoyant force according to the Archimedes principle, and the third one is viscous force. So buoyant force and the viscous force acts in which direction? Upward direction. Buoyant force as well as viscous force always acts in upward direction, while the weight of this metal sphere acts in which direction? Downward direction. When this weight of this metal sphere is balanced by buoyant force as well as viscous force, then what will happen? The metal sphere moves with or attains a uniform velocity or a constant velocity, which is called as terminal velocity. What is the expression for terminal velocity? Terminal velocity is given by V is equal to 2 by 9 into R square into rho minus sigma into G divided by eta, where R is the radius of the metal sphere, rho is the density of the metal sphere, sigma is the density of the liquid, G is the acceleration due to gravity, and rho is the coefficient of viscosity. R means radius of the metal sphere, rho means density of the metal sphere, sigma means density of the liquid with which the metal sphere is moving, G is the acceleration due to gravity, sigma is the coefficient of viscosity. It is about Stokes law and terminal velocity as well as its expression. Next, Poisson's formula. So, Poisson's formula gives the volume of the liquid coming out of the tube. So, if you consider a tube whose two ends are maintained with some pressure difference, then the volume of the liquid coming out of the tube is given by V is equal to pi by 8 into P into R to the power of 4 divided by eta into L, where P is the pressure difference between the two ends, R is the radius of the tube, L is the length of the tube, eta is the coefficient of viscosity. V is equal to pi by 8 into P into R to the power of 4 divided by eta into L gives the volume of the liquid flowing per second. Volume of the liquid flowing per second through the tube. Okay students, next we will discuss one problem related to the terminal velocity. So there are two metal spheres are falling through a liquid of density 2 into 10 power 3 kg per meter cube. In a container there is some liquid which is having the density 2 into 10 power 3 kg per meter cube. Two metal spheres are dropped in the same liquid medium with same uniform speed. They are moving with same uniform speed. The material density of sphere 1 and 2 are given. They are nothing but 8 into 10 power 3 kg per meter cube as well as 7 into 10 power 3 kg per meter cube. You are asked to calculate the ratio of their radii. So there in a container, 2 metal spheres are dropped. The container contains some liquid having the density 2 into 10 power 3 kg per meter cube. Density of the liquid is given, that is 2 into 10 power 3 kg per meter cube. The material density of sphere 1 and 2 are given. I will write material density of sphere 1 as 8 into 10 power 3 kg per meter cube. The material density rho of second sphere, that is also given, 11 into 10 power 3 kg per meter cube. Calculate the ratio of the radii. What about the ratio of radii? R1 by R2 is equal to how much? Rho, sigma as well as R1 and R2. And one more thing, both the spheres are moving with same uniform speed. So Vt1, terminal speed Vt1 is equal to Vt2. Vt1 represents terminal speed of sphere 1, that is equal to Vt2, terminal speed of sphere 2. Since they are moving with same uniform speed, so what is the formula for terminal speed? Vt is equal to 2 by 9 into r square into rho minus sigma into g divided by eta. So 2 by 9 into r square into rho minus sigma into g divided by eta is the formula for terminal velocity. Both the spheres are moving with same liquid. Eta is same. G value is same. So I will write the formula once again. Terminal velocity of first sphere 2 by 9 into r1 square into rho 1 minus sigma into g divided by eta. Similarly, terminal speed of second sphere Vt2 is equal to 2 by 9 into r2 square into rho 2 minus sigma into g divided by eta. In the problem, they are given Vt1 is equal to Vt2. Equate the two equations. 2 by 9 r1 square rho 1 minus sigma into g divided by eta. 2 by 9 into r2 square into rho 2 minus sigma into g divided by eta. Cancel the similar terms on both sides of the equation. 2 by 9 cancel. Eta gets cancelled, g value gets cancelled. Then you get r1 square. Take r2 square to the LHS, it becomes r1 square divided by r2 square. Here in this case, rho 2 minus sigma. Take rho 1 minus sigma to RHS, it goes to the denominator. Rho 1 minus sigma. Substitute the values. Rho 2, 11 into 10 power 3. Minus sigma value is same, that is 2 into 10 power 3 divided by rho 1 value 8 into 10 power 3 minus sigma 2 into 10 power 3. Then it becomes r1 square divided by r2 square is equal to, take 10 power 3 common, 11 minus 2, 9. 9 into 10 power 3 divided by, take 10 power 3 common, 8 minus 2, 6. 6 into 10 power 3, 10 power 3 gets cancelled. Then you can write r1 by r2 whole square is equal to r1 by r2 whole square is equal to 9 by 6. That can be written as 3 by 2. This can be written as r1 by r2. Take square root on both sides, then you get r1 by r2 is equal to 3 by 2 whole to the power of 1 by 2. Ratio of radii is equal to square root of 3 by 2 or the ratio of 3 by 2 whole to the power of 1 by 2. This is how I calculated the ratio of the radii. I will repeat once again. First write the given values, sigma value, density of the liquid given, density of the two metal spheres, rho 1 and rho 2 are given. You are asked to calculate the ratio of R1 and R1 by R2. In the problem itself, we are given Vt1 is equal to Vt2. Next, write the formula for Vt, that means terminal velocity for the two spheres. Right, equate the two equations, similar terms gets cancelled. Then substitute the values of ρ1, ρ2 as well as sigma. Simplify, then you get the answer as 3 by 2 whole to the power of 1 by 2. Okay students, next another important phenomenon exhibited by any fluid is surface tension. So what is tension? Tension is actually nothing but force. Tension is nothing but force. So what is surface? So force at the surface of the free surface of the liquid is nothing but surface tension. So actual definition I will tell later. So surface tension means force acting at the free surface of the liquid is called as acting between the molecules which are present on the free surface of the liquid is called as surface tension. So we know that in between the molecules or in between the atoms there exists an force of attraction or repulsion. So that force is nothing but what? Intermolecular force. The intermolecular force can be further classified into two types. One is cohesive force and another one is adhesive force. The force between the molecules of the same type is known as cohesive force. If you consider water, so what force between the water molecules is nothing but what? Cohesive force. While the force between the molecules of the different type, that is called as adhesive force. So the intermolecular force of attraction or repulsion can be further categorized into two types. One is cohesive force and the other one is adhesive force. So molecules of the same type means cohesive force. Molecules of the different type means adhesive force. So here are few examples in order to understand the nature of these two types of forces. The two drops of liquid can combine because of what? Cohesive force. Two liquid molecules, two water molecules can combine into bigger molecule or bigger drop. That is possible because of what? Cohesive force. It is possible to write on this blackboard by using the chalk. That is because of what? Adhesive forces. Similarly, it is very difficult to, you normally will observe, it is difficult to separate two glass plates if in case water is present in between those two glass plates. That is because of what? Cohesive forces. And the next one is, it is possible to stick two paper pieces. It is possible to join two paper pieces by using what? Gum. That is possible because of what? Adhesive force. So in this case, adhesive force is present in between the paper piece as well as what? Gum. So this is about the cohesive and the adhesive force. Next, we'll move to the very important concept, that is surface tension. So it is the property of the liquid by in which its free surface behaves like a stretched elastic membrane. That property is known as surface tension. Normally, the liquid surface always tries to attain minimum surface area and its surface behaves like a stretched elastic membrane. That property is known as surface tension. It is the property of the liquid by the virtue of which its free surface behaves like a stretched elastic membrane. So if you place your hand on the free surface of the liquid, so normally you will observe, normally you will experience a force, its surface behaves like a membrane, so that property is nothing but surface tension. Best example, insects can crawl on the free surface of the liquid. How they crawl on the free surface of the liquid? The weight of the insects easily balanced by the what? Force due to the surface tension. It is possible to place a tiny needle. It is possible to place a tiny blade on the free surface of the liquid. How it is possible? The weight of the tiny needle as well as the blade as well as the insects supported by the forces due to the surface tension, and hence that is possible. How can you measure the surface tension? So normally, let us consider a vessel which is filled with some liquid or water, any liquid. So on the free surface of the liquid, draw an imaginary line of any length. Draw an imaginary line of any length. So on both sides of this imaginary line, the forces are acting. Both the sides of this imaginary line, the forces are acting. So by measuring this force, you can measure the surface tension. How can you indicate the surface tension? How can you measure the surface tension? Forces acting per unit length on either side of the imaginary line. forces acting per unit length on either side of the imaginary line is called as surface tension. What is the mathematical form? Surface tension is denoted by SRT, that is equal to F divided by L, where F is the force acting per unit length. So such line never exists, it's just an imaginary line. Why we have to draw such line? In order to measure the surface tension, force due to the surface tension, that is given by S is equal to F by L. What is the unit? SI unit of force is Newton, SI unit of length is meter, therefore the unit of surface tension is Newton per meter. Next, we will go through the few simple examples in order to understand the concept of phenomenon of surface tension. First one, so normally liquid droplets, water droplets or any liquid droplets are usually will take the fish shape, spherical shape. That is because of what? Surface tension. As I said earlier, the free surface of the liquid always tries to have minimum surface area. So hence they attain which shape? Spherical shape. Liquid droplets are always spherical. Next one, water wets the glass surface, while mercury does not wet the glass surface. This will depend upon what? Relative strengths of cohesive force as well as what? Adhesive force. Cohesive force is the force between the molecules of the same type, the force between the water molecules, while the adhesive force is the force between the molecules of the different type. For example, the force between the water molecule as well as what? Glass plate, or force between the mercury and the glass plate. So in this case, water wets the glass plate. If you place a drop of water on the glass surface, normally it wets the glass surface. Why means in this case, the adhesive force between the water molecule and the glass is greater than the cohesive force between the glass molecules. That's why water wets the glass surface. The adhesive force between the liquid water molecule and the glass is very large when compared to cohesive force between the water molecules, and hence water wets the glass surface. While in case mercury, if you place a drop of mercury on glass plate, normally it does not wet the glass surface. Why means in this case, the adhesive force between what? Adhesive force between the mercury and the glass plate is larger when compared to the cohesive force between the mercury molecules is very large when compared to the adhesive force between the mercury and the glass plate. I will repeat once again, mercury does not wet the glass surface. Reason means here the cohesive force between the mercury molecules is very large when compared to the adhesive force between the mercury and the glass plate, and hence the mercury does not wet the glass surface. Next, it is possible to place a tiny needle on the surface of water. As I said earlier, it is possible to place a tiny needle or paper piece, or as well as insects can crawl on the free surface of the liquid. That is also possible because of what? Surface tension. Next, normally you will observe oil spreads on the cold water while it continues to remain as a droplet on the surface of the hot water. Reason why means surface tension of oil is greater than the surface tension of oil is less than the cold water, but it is greater than the hot water. Surface tension of oil is less than the cold water, but it is greater than the hot water, and hence it is continues to remain as a droplet on the free surface of the liquid. And also you normally will observe, for example, paint brush. When you immerse the paint brush in any liquid, so the hairs are spreads out. So when you take out the paint brush from the water, what will happen? Once again, the hairs of the paint brush comes closer. Reason why means the free surface of the liquid always tries to have what type of area? Minimum surface area. Okay students, next another theory related to the surface tension, that is molecular theory. So here there is a vessel which contains some liquid, for example water. So I will consider three different molecules A, B and C. One molecule lies well inside the liquid, so it is equally attracted by all the neighboring molecules. So this molecule will be attracted by this one, this one, this one and this one. So therefore, what about the net force? If the molecule is equally attracted by all the other molecules, then the net force will be acted upon and it will be equal to how much? 0 only. For example, I will consider one particle here. It is attracted by a force in this direction also. It will attracted by equal amount of force in the opposite direction also. Then what about the net force? The net force will be equal to 0. Therefore, for the liquid molecule A, the net force acting on it will be equal to 0. Similarly, consider other molecule B. This molecule also equally attracted by all the surrounding molecules. Therefore, the net force acting on the molecule B is also equal to 0. Next one is third molecule. Is if this molecule lies at the surface only. So on this molecule, it is half of this molecule lies inside the liquid, while the remaining half lies outside the liquid. Outside means it is in which medium? It is an air medium. Half the portion of the liquid molecule lies inside the liquid, while the remaining half lies outside the liquid. So here, what about the net force? Here in this case, the net force will not be equal to 0. So this molecule will be attracted by all the other molecules lies inside the liquid. Therefore, in this case, the net force acting on this will not be equal to 0. So in which direction the net force is acting? So the net force will be acting in which direction? Downward direction only. Now, if you want to bring this molecule to the surface, if you want to bring the molecule A to the surface, B to the surface, what has to be done? What has to be done? Is it right? Since it is equally attracted by all the surrounding molecules, when you try to push this molecule to the surface, it is equally attracted by all the neighboring molecules. Therefore, work has to be done. You know that work done is always stored in which form? In which form of energy? Potential energy. The potential energy of the molecules which are present at the surface per unit area, that is called as surface energy. The potential energy of the molecules which are at the surface of the liquid is called as surface energy. What is the formula for surface energy? That is given by work done is equal to TRS, which is nothing but surface tension into delta E. Delta E represents small change in area. So work done in order to bring the molecules to the free surface, or that is nothing but potential energy, stored energy. Potential energy of the molecules which are present at the surface is given by surface tension into increasing area. Next, shape of the liquid meniscus. So there are two containers and there are two capillary tubes. Capillary tube means small glass tubes whose hole or the radius is very small when compared to its length. They are placed in two different containers. Here in one container is filled with water and another container is filled with mercury. One container filled with water and the other container filled with mercury. When you place the capillary tube in the container containing water, you will observe that near the point of contact between the glass and the water, what will happen? So there will be a change in the shape of the liquid. The shape of the liquid gets changed. So when you immerse the capillary tube in the container containing water, the shape of the meniscus will be concave. So in case if you immerse the capillary tube in a container which is filled with mercury, you will observe that the shape of the meniscus will be convex. So next, angle of contact. Angle of contact is nothing but the angle between the tangent. This is the tangent to the liquid surface and this is the solid surface. Here a liquid is placed on the solid surface. The angle between the tangent drawn to the liquid surface and the solid surface inside the liquid is called as angle of contact. So here water is placed on any solid surface, for example glass. When you place the water on the glass surface and draw a tangent to the surface of the water droplet, this angle theta, which is the angle between the tangent and the solid surface inside the liquid, that angle is called as what? Angle of contact. In this case, angle of contact will be equal to how much? Acute. Less than 90 degree. Acute. Next, if you place a mercury droplet on the glass plate, then draw a tangent to the mercury droplet. In this case, the angle between the tangent drawn to the mercury droplet and the solid surface inside the liquid or mercury is greater than 90 degree. This angle theta is called as angle of contact. In this case, angle of contact is more than 90 degree and hence it is obtuse angle. Water wets the glass surface while mercury does not wet the glass surface. That is also because of what? Surface tension. Next, capillary. Capillary is nothing but rise and fall in the liquid level. Rise or fall in the liquid level when a capillary tube is immersed in a liquid is called as capillarity. Capillarity means rise or fall in the level of liquid. When a capillary tube is placed in the liquid is known as capillarity. So when you place the capillary tube in a container filled with water, the liquid level rises. Why? When you place the same capillary tube in a vessel filled with mercury, the level of the liquid decreases inside the tube. That is called as capillarity. There is a formula which is used to calculate the height attained by the liquid level inside the tube. That is called as ascent formula. Ascent formula gives the height of the liquid level in the capillary tube. That is given by H is equal to 2 into T into cos theta divided by R into rho into G, where T is the surface tension, theta is the angle of contact, R is the radius of the capillary tube, rho is the density of the liquid, where G is the acceleration due to gravity. Here T, theta, rho and G all are constants. That means H is inversely proportional to R. Height attained by the level of liquid is inversely proportional to the radius of the tube. If the radius of the tube is more, height attained by the liquid level will be less. They are inversely related with each other. This is about the molecular theory, the surface energy, the formula for surface energy, and the shape of the liquid meniscus in a capillary tube, as well as angle of contact, capillarity, ascent formula, and how the height attained by the liquid level is related with what? Radius of the capillary tube. Thanks.